Every few weeks, like clockwork, another sensational headline sweeps across our digital feeds, boldly claiming that artificial intelligence is on the absolute verge of replacing millions of human jobs. The narrative is always identical, painting a picture of an imminent societal shift where software engineers, graphic designers, corporate lawyers, teachers, and even specialized medical doctors are cast aside by algorithms. If you listen to the tech evangelists and hyper-enthusiastic commentators, the future they describe sounds not just plausible, but completely and utterly inevitable. They want us to believe that autonomous machines will seamlessly assume all cognitive work, while human employees are inevitably left obsolete. But when you look beneath the marketing metrics, there is one massive, foundational problem with that hyperinflated narrative. The messy reality of enterprise operations is far more complicated than the superficial headlines suggest. The reason full human replacement remains a distant illusion is that displacing an experienced workforce is never simply a technology problem. In the real world, it is wrapped inside a dense web of overlapping constraints. It is an intricate business problem of aligning organizational efficiency. It is a terrifying legal problem of mapping liability. It is a strict financial problem of analyzing return on capital investment. And fundamentally, it is a staggering operational problem of execution. Most mainstream conversations about generative AI focus exclusively on raw capability, on what the technology can do in an isolated, idealized demonstration. But within the demanding matrix of real-world enterprise infrastructure, technical capability alone is never enough to justify pulling down the human scaffolding that keeps an industry standing. When you filter out the noise, you discover there are actually 4 major real-world barriers slowing down and actively preventing full AI human replacement across the globe. These systemic forces are reliability, accountability, cost, and integration. Together, they form what I define as the RACI framework. Once you strip away the science fiction hype and begin analyzing the future of labor through these 4 harsh operational lenses, the trajectory of artificial intelligence suddenly looks radically different. It stops looking like an instant human erasure and begins looking much more realistic, grounded, and manageable. Let us dismantle the very first barrier, reliability. Large language models and generative neural networks are undeniably impressive, often producing outputs that feel downright magical. But inside an ongoing operational pipeline, they suffer from a fatal flaw. They fail in surprisingly unpredictable, simple, and catastrophic ways. The core issue isn't merely that they make mistakes. It is that their underlying architecture dictates that they express their outputs with absolute, unwavering confidence even when the data they are delivering is completely, fundamentally wrong. In the precision-driven arena of business, a system that is right 90% of the time but masks its 10% failures with absolute certainty is an active liability. To truly understand the reliability crisis, look no further than autonomous vehicles. Under controlled testing environments and pristine, sunny highway data profiles, their neural networks perform with remarkable accuracy. But our real-world cities are fundamentally chaotic, messy, and unpredictable environments. Think of blinding torrential rain obscuring lane markers, unexpected construction detours with handwritten detour boards, or an erratic pedestrian stepping off a curb outside a crosswalk. These are fluid, high-context scenarios that a human driver assesses and navigates instinctively through nuance. For a machine, however, this sudden influx of chaotic, unmapped data forces sensor systems into immediate confusion. When reality collides with an algorithm, the neat logic of software breaks down completely. This exact reliability crisis is actively disrupting professional white-collar spaces. Consider the high-profile legal disasters where practicing corporate attorneys trusted AI-generated legal research only to present briefs before a judge containing completely fictional court citations. The AI had hallucinated entire legal precedents out of thin air. The formatting of the text looked flawless, the legal terminology sounded completely authoritative, and the logical structure was incredibly convincing. Yet, the core data was completely fabricated. In high-stakes enterprise environments where a single administrative error can trigger multimillion-dollar class action lawsuits or systemic compliance shutdowns, relying on a system that fabricates truth is a gamble no serious business can afford. If a consumer entertainment chatbot recommends the wrong movie or hallucinates a historical date during a casual search, the real-world consequence is completely harmless. But when an enterprise AI engine hallucinates a diagnostic marker during an oncology scan, or miscalculates a chemical threshold inside an active industrial processing plant, we enter an entirely different risk paradigm. The greater the real-world consequences of an error, the higher the operational standards become. This is why human workers remain an absolute operational requirement. High-consequence environments do not merely look for speed. They demand absolute, verifiable reliability. This leads us directly into the second massive barrier: accountability. When a human employee makes a catastrophic operational error on the job, the chain of custody and legal responsibility is immediately clear. But when an autonomous algorithm executes a critical decision that results in massive financial or physical damage, the legal framework shatters completely. Who steps forward to shoulder the blame? Is it the third-party software developer who wrote the model? Is it the data engineer who oversaw the training dataset? Is it the corporate enterprise that deployed the application? Or is it the chief executive who signed off on the operational integration? In the modern economy, responsibility cannot exist in a vacuum. Until the legal system establishes clear liability, humans must remain in the loop. In the high-stakes world of modern healthcare, the accountability vacuum is a matter of life and death. If a medical imaging algorithm fails to detect an early-stage malignant tumor on a critical brain scan, the diagnostic failure can shorten a patient's life. If a hospital replaces its expert human radiologist with an automated system, who is legally liable for that misdiagnosis? Is it the software vendor or the hospital administration? Most medical networks and clinical institutions are simply not willing to gamble their corporate survival and patient safety on black box algorithms whose internal logical steps cannot be explained, audited, or legally defended in a court of law. A perfect parallel exists inside the commercial aviation sector. Modern passenger aircraft are already marvels of absolute automation, fully capable of takeoff, navigation, and landing via advanced autopilot systems. Yet, global airlines and regulatory bodies still demand two highly trained human pilots sit inside the cockpit on every flight. Why? Because when unmapped emergency variables occur at 30,000 feet, human judgment, quick context processing, and absolute accountability are the ultimate safety nets. If an automated flight computer errors out, an algorithm cannot be held legally or morally responsible for the lives on board. True automation still requires human oversight. Let us confront the third foundational barrier: cost. There is a universal corporate assumption that switching from human workers to artificial intelligence instantly collapses operational expenses down to zero. In reality, deploying enterprise-grade AI frameworks at a global scale is an incredibly expensive technological endeavor. Training a single frontier model requires tens of millions of dollars in continuous specialized processing power. Running those models at scale demands massive, dedicated cloud infrastructure, and maintaining those models requires a constant stream of elite engineering talent. When you look at the raw financial metrics, AI doesn't just eliminate costs, it shifts them into massive infrastructure capital expenditures. And then there are the hidden costs: employee retraining, consulting projects, data cleanup, cybersecurity, system redesign. Many organizations discover that before AI delivers meaningful value, years of preparation work may be required first. This brings us to the final and arguably most difficult barrier of all: integration. Mainstream tech commentary talks about AI as if it can be cleanly dropped into any business like an app on a smartphone. But real-world companies are not clean, modern, unified systems. They are incredibly complex operational ecosystems built organically over decades of survival. They are held together by legacy software architectures from the 90s, outdated heavy machinery, completely disconnected regional databases, manual human spreadsheets, and temporary procedural workarounds. An advanced AI model doesn't operate in a vacuum. It must somehow fit into this messy reality. Take manufacturing as an example. A single factory may contain machines from 10 different vendors, different communication standards, different software generations. Some equipment may still be running technology installed more than 15 years ago. Yet everything must work together before AI can even begin operating effectively. Healthcare faces the same challenge. Hospitals often rely on multiple disconnected systems for patient records, imaging, scheduling, insurance, and administration. Adding AI into that environment is not simple, and this is one reason many AI pilot projects fail to scale successfully. Now, analyzing these four massive race barriers does not mean that artificial intelligence is overhyped or destined to fail. Quite the contrary. AI will absolutely transform the global industrial landscape over the next decade. It will successfully automate millions of tedious, repetitive tasks. It will supercharge human data productivity. It will accelerate complex decision-making frameworks. And it will help modern enterprises operate with unprecedented structural efficiency. But systemic industrial transformation is not the same thing as direct human replacement. The economic future of our world is not a dystopian battle of humans versus machines. The real future is collaborative, humans working alongside increasingly intelligent cognitive software platforms. The organizations, institutions, and professionals that learn to combine the irreplaceable value of human judgment, empathy, and accountability with the raw processing power of machine intelligence are the ones that will win the future. And perhaps that is the single biggest misunderstanding in the entire global debate surrounding artificial intelligence. The hardest part of this technological revolution is not the science of building the models. The real challenge is the operational art of integrating that advanced technology into the messy, highly complex, and beautiful reality of our daily lives. In our very next video, we are going to dive deep into the corporate boardroom blunders of automation, exploring why so many modern organizations approach their AI strategy completely backwards, and why the technology is actually the easiest part of digital transformation.